Okay, amazing people. Now we've got one more example here. In this case here, we've got two lines we need to graph. So there's going to be two intersecting regions, which we need to then work out to satisfy both of these. Now, one of the first things we need to do here is we need to be able to solve these simultaneously. So we've got equation 1 and equation 2 here. Now, in order to do this, what we need to do is solve. I'm going to use elimination in this case. So I'm going to have equation 1 and add equation 2 to it. So as I do this now, that's going to give me 6x, and that's going to be equal to, now I've dropped the greater than or equal to signs here just because it doesn't give me a true indication for what I'm about to do. And that's going to be equal to 12. As I solve this, so dividing both sides by 6, this is giving me x is equal to 2. Now I just need to substitute x equals 2 into one of these equations. I'm going to substitute it into equation 1 and solve that. So that's going to give me 2 plus y is equal to 7. Moving the 2 to the other side, that gives me y is equal to 5. So what I'm plotting here is the point where these two lines are going to be crossing over one another. Now, also what I want to do is I want to find out where their x and y intercepts are for these lines. So for the first one, I'm going to have x plus y equals 7. I'm going to let, in this case, x equal 0. That means I've got y equals 7. And if I let y equals 0, that's going to give me also x equals 7. So I've got that first intercept the intercepts for that first line. Now for the next one, which is 5x minus y equals 5. First instance, I'm going to let x equals 0, and when I do that and solve it, that's going to give me y equals -5. And also, I'm going to have y equals 0, and when I do that, that's going to give me x is equal to 1. So now that I've got all my intercepts, I can begin to plot these points. Now, first instance of the first line, what I had was 7 and 7, so that's going to be, say, here and here. Okay, so I've got both points here, and I can start to draw this line as well. So this is going to be an unbroken line here. I mean, a broken line in this case, because it is greater than only. And so there we go, I've got that line there. Next up, what we want to do is we want to plot the other line here. So this other line is -5, will be about here, and x equals 1, which will be at this point here. And this one is going to be a solid line because it is greater than or equal to in this case. So it's going to be roughly there. Now I can also plot the points where they are intercepting, which is this point here. And these values are going to be 2 and 5. Now, in addition to this, one thing I need to do is I do have to test some points here. So what I want to do is I want to split these regions up. So what I might do is I'm going to assign some values to test here. So what I'm going to do, I'm going to put 1 as A, and I'm going to make this 2 and 0. So I'm choosing nice, easy points to test. So that's it there at A. For point B, because effectively we've got 4 different regions to test here. For this one here, what I'm going to use is I'm going to use 0 and 2, again, keeping it simple. So that's going to be about there. So that's point B. For the next one, which is point C, this one here is going to be 2 and 7, because I know that's going to be above. So I'm going to go to 2 and 7. So that's going to be about here. That's going to be my point C. And then in addition to this, I'm going to do a point D. And this one is going to be 7 and 2. And this one is going to be about, that's going to be my point D. Okay. Now, as I test each of these, I'm just trying to see which ones kind of work and satisfy this. Now, in first case here, point A, when I substitute this into equation 1, that means I'm getting 2 is greater than 7. That doesn't work. So straight away, I've got an indication that it doesn't work. So that one can be crossed off. Okay, doesn't work. Okay, point B, I've got 0, 2. Let's substitute it into equation 1. So as I substitute this in here, that means I'm going to have, again, 2 greater than 7. That doesn't work. Okay, if it doesn't satisfy one of the equations, it doesn't work at all. Okay, next one, point C. Let's try this one. So I've got 2 and 7. So if I substitute this into equation 1, that gives me 2 plus 7 is 9 greater than 7. It works for the first equation. So we have an indication that this one could be a possibility. Now what we're going to do is we're going to substitute it into the second equation. So in that case here, that gives me 5 times 2, which is 10, minus 7, which is 3. 3 is greater than or equal to 5. No, it's not. So that one doesn't work. So lastly, we test point D. So 7 plus 2 gives us 9, which is greater than 7. So it works for equation 1. Then we've got equation 2. So we've got to substitute it in. 5 times 7, well, that's 35. Plus 2 is 33. Is 33 greater than or equal to 5? Yes, it is. So this is the region here, which we have to shade in. So that means it's D. And you can see where I've got my point here. That's going to be this region over here, which satisfies both of these equations. So this is an extra task with a few more things to work out. Again, we can still work out the region that needs to be shaded just by a little bit of trial and error.